We've been studying fire since before we had electricity. And so we do know a lot about fire. There's a lot of long-term knowledge about how fire behaves in a system, how fire is good for systems, and why we need fire. But there are still fundamental questions about how we can study fire, how we can detect fire, and where we can detect fire. There's a real need for identifying technology that we can use, here on an aircraft or on a sensor, as well as tools and technology that we can use in Earth orbit to help support proactive wildland fire management. Fire is a natural part of the Earth system, and because fire has been part of the Earth for so many thousands of years, we actually have fire-adapted ecosystems. And so in areas where you have regular wildfire, you require fire for that system to be healthy and resilient.
NASA FireSense is a project focused on developing and delivering NASA technology, including Earth observation data and modeling and science to land managers that manage wildland fire.
This week, we're partnering with Fort Stewart, which is in Georgia. And so an important part of the FireSense campaigns are these partnerships between a number of different types of agencies and collaborators.
Everything we do on test and training ranges has potential to start fires. And to mitigate that wildfire risk, we use a lot of prescribed fire, in fact, more than almost any other federal landowner.
By keeping these fuel levels so low like this, when we do have wildfires occur, they can be suppressed very easily. We don't have to interrupt military training. And then also on Fort Stewart, we have several threatened and endangered species. This whole ecosystem is fire dependent out here. And so by implementing prescribed fire on a 2 to 3 year basis, that maintains that habitat for red cockaded woodpecker, gopher tortoise, eastern indigo snake, all these species of concern like that.
So this prescribed fire is in support of critical research that allows us to test and evaluate various satellites and airborne platforms to look at and study fire.
The multi-scale approach that we're employing here at Fort Stewart is something that we've been trying to do in the fire science community for a long time, and it's a very difficult thing to do. When you're working with fire that's very dynamic, getting everything to align along with the satellite observations has sort of been the holy grail in fire science for a long time.
Let's go ahead and get
efficient.
That's really amazing
If
that you
you-
can see it at that level of detail.
Do you see the plane?
Oh,
that's cool.
There it is. So it just updated. So within FireSense on the field campaigns for 2025, we have coordinated satellite, so sensors within Earth orbit. We have 3 crewed aircraft with 4 sensors on board looking at information before the fire happens, during the fire, and after the fire. And each of those sensors looks at different aspects of the system, and so they're giving you different information. So you can use that all together. And then we have ground sensors. And so all of these pieces together, we can use those to improve models in the long term. And then we can use them immediately to give information to burn crews so that they know if they need to add more lines of ignition to a prescribed fire, or if they need to add resources to one side so that they can help contain a fire. It gives them information that they need immediately in real time.
And anything that provides us extra data for our decision making, for our why we did this particular day, anything that can help back up that decision making process is extremely beneficial.
All this knowledge that some of it has been broken traditionally over the years or separated. But there's some cultures in the United States and certainly in other parts of the world that continued their way of burning. And now we have science in a way validating what happened and what is happening. And I think it'll help us in the future.
So much of what we manage across the continental United States depends on remote sensing. So we hope that this effort validates those remote sensing platforms and allows organizations like NASA and its FireSense campaign to really support the broader wildland fire community, the urban interface by really providing real-time assets with quality control, validation in the field, so that as we address the nation's wildfire challenges, we do so with the best available tools and technology.
All right, on. So I'm going to check that the ship disc is mounted.
One of the exciting parts of this spring 2025 campaign for FireSense is we're getting feedback on real-time data. And so one of those systems is the NASA JPL Avarice 3 system. We have real-time spectroscopic products. And what that gives us is a picture of what's happening during a fire. And so you can see active fire progression. Every couple of minutes, it will give you a picture of where the fire is. Right now, we're getting feedback through a technician who's on the ground that can then talk to the burn crew on the fire line and provide feedback on what's useful, what they like, and then make adjustments.
Avarice 3 is a digital sensor, and unlike a digital camera that shows us, a regular image, we are able to see many more wavelengths with Avarice because they use a diffraction grating that's able to split the light into these hundreds of wavelengths instead of just a few.
What we're doing is we're measuring the light from the ground or sunlight reflected from the ground. So we're not sending any signal down from the instrument, but everything that's from the Earth's surface is coming up and through this window into the instrument.
This is brand new, especially at this pace. So the 3 to 5 minute downlink of data is really cutting edge, and it's really exciting to have that near real time product that we're able to provide to the foresters and the fire managers on the ground. On our campaign a few weeks ago, Avarice was able to spot new wildfires while they were flying.
We ended up finding more wildfires than we initially had anticipated, but that was also due to the weather and the situation that was happening. We gave our sensor teams and our pilots some ability to make corrections in the air, and we had communication with our teams so that we could be dynamic and be really responsive to this very unplanned environment.
I was able to pull that data down within a few minutes and provide maps of new starts to forestry managers on the ground who are able to deploy resources to these wildfires. So in that context, that near real-time pace is really critical for deploying resources and managing those wildfires and protecting property and things like that.
with satellite collection, you have to identify the time that the satellite is passing over. And so you get persistent coverage with crewed aircraft in comparison to a satellite.
We might get 2 to 4 looks at a fire per day, which is really useful information, but it doesn't have that high temporal frequency. When we can do this from aircraft and send data down almost immediately from the plane, we get that added perspective of delivering that higher resolution time information.
Fire is a mobile disturbance. And so fire impacts all aspects of the Earth system. It's going to impact the soil, it's going to impact the vegetation, it creates smoke, which is then carried through the air, so it impacts our atmosphere. The fire behavior itself generates its own weather. And so because of all of these different systems, we need different scientists who have expertise in all of these pieces. And so on campaigns, we have integrated teams so that we have integrated data.
Collaboration is built into fire management, whether it's initial attack and mutual aid response or research and development. We all bring certain perspectives, tools, technology to research, and in this case, to be able to deploy them together gives us synergies that just would not be possible if we go it alone.
The way that FireSense will be successful is by working directly with local partners so that we can support decision-making that they're doing on the ground.
In other words, this helps us flatten out the training curve. Fires are getting more and more intense, more and more severe, and being in places where it's been rare historically for them to be. So the next generation of fire scientists and firefighters are going to have something to anchor into as they progress in future and changing conditions.